Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Find the derivative from the left and from the right at x equal to 1 if they exist of the following function. Are the functions differentiable at x equals 1, right? So we've got f of x which is equal to x when x less than or equal to 1, and then it takes a parabolic curve x square when x greater than 1, right? So we've been asked to find the L left hand derivative and the right hand derivative. So let's quickly write that down. We will start off with our right hand derivative. So my right hand derivative is f dash x naught plus. And what is my x naught in this case? I've been asked to examine the differentiability at 1. And wherever I have x naught, I can comfortably replace it by 1. And therefore, to calculate my RHD, I have to find out what we have on our screen, right? Limit h tending to 0, f of 1 plus h minus f of 1 divided by h, right? So my f of 1 is, let me move to the next line. My f of 1 is nothing but x, right? Because for x equal to 1, we have f of x taking the value x. So we have that as 1. And for f of 1 plus h, which means that x is greater than 1, right? We've got the function f of x taking the value 1 plus h the whole square, right? Because it will take x square, and therefore we will have to write our expression as 1 plus h the whole square. That's going to be my f of 1 plus h. And I have my minus of f of 1, which we just discussed. And we have it as an x, which is nothing but a 1, divided by h, right? So this is what we have. And what is my numerator? My numerator 1 plus h the whole square is nothing but of the format a plus b the whole square. So 1 plus h square plus 2h. And then you still have a minus 1. And I think my 1 and 1 in the numerator will get cancelled, and I will be left with h square plus 2h, right? So I'll be left with h square plus 2h. And remember, I have my h in the denominator, and I can pull out 1h and cancel that out, which means I'll be left with a h plus 2, right? Yeah. So h tends to 0. I don't think we can further simplify this. We have our RHD equals 2, right? And let's move to our LHD now. So we know that the RHD is finite and it exists. So let's calculate our LHD. So there we have the LHD on our screen. LHD equals f dash of x naught minus limit h tending to 0, f of x naught minus h minus f of x naught divided by minus h, right? And what is our x naught? Our x naught is nothing but your 1. And wherever I have x naught, I can comfortably substitute it by a 1. F of x naught becomes f of 1, right? So this is our LHD, and let's move to the next line. So we have 1 minus h, right? And what does that mean? That means x is going to take a value which is lesser than 1, but it could be very close to 1. So then we have our equation x coming into the picture, right? So let's write that. So my f of 1 minus h will have to be represented by x, right? So I replace x by 1 minus h. So I have my 1 minus h minus f of 1 is again exactly the same as what we calculated when working out our RHD. And then I have my minus h in the bottom, right? So I have 1 minus h minus 1 in the numerator, and I have a minus h in the denominator. That leaves me with minus h by minus h, right? Which is nothing but 1, right? So we have our LHD as well, which is equal to 1. So my LHD is equal to 1 and my RHT is equal to 2, right? And what does that mean? My LHT not equals RHT, right? And therefore, and the function is not differentiable at x equals 1, right? I hope you found this content useful. Please do subscribe to my channel and support. Thank you.